Hello everyone. Today we will going to start the properties of subtraction of the integers. Okay, so these are some of the properties of the subtraction. So we will see one by one in detail about these properties. So the first one is your closure property. So in the closure property, as it says, we have to take the integers, okay, and we have to perform the given operation, that is subtraction. And if the answer is also an integer, then we can say our closure property holds true for that particular operation. Okay, so subtraction of two integer will always gives an integer. So here, whenever we will subtract two integer, that is 6 minus 3, we are getting 3. So 6 is an integer, 3 is an integer. We are performing the subtraction, we are getting 3, which is also an integer. Similarly, if we will take one negative integer and one positive integer and then perform the operation of subtraction, we are getting minus 6, which is also an integer. And if we will take both the negative integer and then perform the subtraction, then this minus and this minus will get multiplied, it will give you plus. So minus 7 plus 6, which will give you minus 1, which is also an integer. So in these three cases, we have found that subtracting two integers, we are always getting an integer. So for the subtraction, our closure property holds true. Now next one is our commutative property. In the commutative property, it is a minus b, and then in the second case we have to interchange the places of the integer. But in the case of subtraction, the commutative property doesn't hold true, that is a minus b is not equal to b minus a. Like for example, if we will take an integer 4 and integer 2 and then we will subtract them, that is 4 minus 2, we will get 2. But if we will interchange the places of the integer, that is if we will write the integer 2 at the first and integer 4 at the second, and then we will perform the subtraction, we will get minus 2. So for the subtraction, our commutative property doesn't hold true, because you can see over there the answers are not same when the integers are interchanged their places. Our third property is associative property. So in the associative property, we have to take three integers, we have to group any two and then perform the operation, then whatever result we will get, then we have to perform the same operation with the third integer. Now in the case of subtraction, the associative property, that is a minus b minus c, is not equal to a minus b and then minus c. So let us see one example. That is, I have taken three integer, the 2, 6 and 4. So first I have operated, that is first I will do the subtraction of 6 minus 4, I will get 2, and then I will do the subtraction of 2 which is outside the bracket, that is 2 minus 2, I will get 0 in this case. Now when I will group the first two, that is 2 and 6, this I will group and I will subtract them at the first. So 2 minus 6, I have got minus 4, and outside minus 4 is already there. So in this case I got minus 8, and it is quite clear that whenever I have changed the grouping, that is the steps of operation, that is steps of subtraction, whenever I have changed it, that first I have subtracted 6 minus 4, then I have subtracted with 2, I got 0 here. Now in the second case, I have subtracted 2 and 6 and then I have subtracted it with 4, then I got minus 8. So in both the results are not equal, so we can say that a minus b minus c is not equal to a minus b minus c, and thus we can say that associative property for the subtraction doesn't hold true. So for the subtraction, only our closure property holds true, whereas commutative property and associative property doesn't hold true. Okay, so now we will see the property of division of integer. So again, for the property of division of the integer, we will start with the closure property. As the closure property says, the division, that is, whenever we are taking the integer and then performing that particular operation, our answer should also be integer. But in the case of division, the division of two integer may or may not gives an integer. So let us see here with the example. So if I will take a division of 4 with the 2, that is 4 divided by 2, I am getting over here 2 as an answer. But if I will take 6 divided by 10, I am getting over here 3 by 5, which is a fraction. Or if I will write it down in this form, that is 0.6, which is a decimal. So 6 is an integer, 10 is an integer, but when I am dividing it, I am getting either a fraction or a decimal number which is not an integer. So division of integer, sometimes it gives an integer, but every time it will not gives an integer. So for the closure property of division, our closure property doesn't hold true for the case of division. Now let us see the commutative property. In the commutative property, a divided by b, and then we have to interchange the places, that is b divided by a. In this case, a divided by b is not equal to b divided by a. Let us see. Suppose I take 10 divided by 5, so I am getting 2 over here. But when I will interchange the places, that is 5 divided by 10, I am getting over here either 5 by 10 or 1 by 2 or 0.5. You can see here in the first case I got 2, but when the integers interchange their places, I got either 1 by 2 or 0.5, which are not equal. So our commutative property for division doesn't hold true, that is a divided by b is not equal to b divided by a. Third one is associative property. Here we have to take 3 integer and then perform the operation, and in this case also a divided by b divided by c is not equal to a divided b divided c. So here, when I have taken 3 integers 6, 4 and 2, so 6 divided 4 divided by 2. So first of all we will divide 4 and 2 over here. So when we divide 4 divided by 2, we got 2, and then 6 divided by 2, we got 3. Now we will group 6 and 4. So 6 divided by 4, I got 1.5. Then 1.5 divided by 2, I got 0.75. So here it is quite clear that 3, that is in this case when I follow the grouping, that is 4 divided by 2 at the first, I got 3 as the answer. But when I have grouped 6 divided by 4, I got 0.75 as the answer. So for the division, our associative property doesn't hold true in the case of division. Okay, so our next property is property of 1 and property of -1. Any integer divided by 1, it will keeps the same integer. For example, if I will divide 5 with 1, I will get 5 as the answer. If I will divide -6 with 1, I will get -6 as the answer. So any integer being divided by 1, we will get the same integer, whether it is a positive integer or negative integer. If it is divided by 1, we will get the same integer. Just opposite of it, when we are dividing any integer with -1, we will get the same integer with the change in the sign. That is, the sign of the integer will be changed. If it is a positive integer I have taken, it will become negative. If it is a negative integer, it will become positive. For example, if 12 is divided by -1, we will get -12. Here you can see that 12 is a positive integer, but when it is divided by -1, we will get a -12. And when -17 is divided by -1, we get +17. Here I have taken a negative integer, that is -17, When it is divided by -1, we got plus 17 as the answer. The last property of the division is property of 0 and the division of any integer by 0. So in the case of property of 0, 0 divided by any integer will gives you a 0. It is the property of 0. That is, if 0 is divided by 11, we got 0. 0 divided by -5, we got 0. So if you, whether you will take a positive integer or you will take a negative integer, if 0 is divided by any integer, whether positive or negative, the answer, that is the quotient, will always be 0. The last property is any integer being divided by 0 is not defined. That is, that number is not defined. That is a meaningless. So if 13 is divided by 0, not defined. -4, that is negative integer, divided by 0 is not defined. So any integer divided by 0 is not defined. That is meaningless. Now we will see that how we can simplify an expression by using a certain rule that is known as your BODMAS rule. Okay, so here simplification of expressions by using BODMAS rule. First of all, we will see what is this BODMAS rule. So in the BODMAS rule, it resembles certain operations, like for example B resembles to bracket, O resembles to of, D for division, M for multiplication, A for addition, and S for subtraction. So this is the steps, that is, this is the sequence which we have to follow while we are simplifying an expression which contains two or more than two operations at a time. Okay, so first of all we have to solve the bracket, whatever is inside the bracket. If it is addition, multiplication, division, subtraction, whatever is there, first we have to solve inside the bracket. Then we have to solve the of, then we have to solve the division, then multiplication, then addition, and at the last the subtraction is being simplified. Now in the bracket we have four types of bracket. The first one is your line or base or vinculum bracket. The second one is your small bracket. The third one is your curly bracket, and the fourth one is your square bracket. Like if you will see over here one expression, okay, so in this expression you can see that over this expression 16 minus 2, one line is given. This line is known as your line bracket or base or vinculum bracket. After this you can see a small bracket like this, then you have a curly bracket in this way, and then you have a square bracket at the last. So in solving the bracket we have to follow these steps. That is, first we have to solve the line bracket, then we have to solve the small bracket, then the curly bracket, then the square bracket. After that it comes the of. Of means, suppose sometimes we say 5 by 2 of 4. It means that this of is being replaced by multiplication sign, that is 5 by 2 into 4, and then we will write 10. Okay, so this is the simplification for the of. Okay, so in the BODMAS rule, the first which was being solved is the bracket. In the bracket also it is the line bracket first, then small bracket, then curly bracket, then square bracket. Then of we have to solve. Of is being replaced by multiplication sign, but don't confuse, it is not a multiplication. If multiplication and of are there, first we have to solve of, then multiplication. After of, the third one is division, then multiplication, then addition, and then the subtraction. Now let us take one example where this expression contains more than two or many operations, like division is there, subtraction, multiplication, brackets are there. So let us see how we will solve this kind of expression. So first of all, we have to solve the bracket. In the bracket also, first we have to solve this bar bracket. Okay, so inside the bar, which expressions are there that we have to solve? So here inside the line or inside the when column bracket, we have 16 minus 2. So first we will solve 16 minus 2, and never solve 2 or 3 operations together. Like we are solving this also, we are solving here also. So that should not be do. At a time we have to solve only one expression. So first is the line bracket. So 16 minus 2 is 14, and all other expressions, the numbers should be written as it is. Now after that we have to solve the bracket, small bracket. Inside the small bracket we have 14 divided by minus 7, so we will get minus 2. After that we have to solve the curly bracket. So in the curly bracket we have 2 into minus 2, that is minus 4. After that we have this division, so 4 divided by minus 4 is giving you minus 1, and then outside minus is there, so minus 6 as it is. Then minus and minus will be plus, then 6 plus 1, we will get 7 as the answer. So in this way we will going to solve any expression by using this BODMAS rule. Okay, so after the properties of subtraction and division of the integer, we will see how we are going to solve some exercise questions. Okay, so for that I have taken one exercise question, that is exercise 1b, page number 17, question number 4, number A. So here is the question. Here you have to prove that the following statements are false, and you have to give the reason that why it is false. So here I have taken one question, that is number A. We have to prove that yes, this statement is not equal, means they are not equal, they are false, and why it is false. So why it is false we will show by showing the process. Okay, so every time whenever we have to show some verification, we are doing LHS and RHS. So in the LHS we will write the left hand side of the equal to sign. In the RHS we will write the right hand side of the equal to sign. So here left hand side is 18 minus 6 plus 3, and right hand side is 18 minus in bracket 6 plus 3. Now here first we will solve this small bracket. So in the small bracket 18 minus 6 is there, which is 12. Then 12 plus 3 is 15. Here first we will solve this bracket. So 6 plus 3 is 9, 18 minus 9 is 9. So what we found it that our LHS is not equal to our RHS. That is, in the left hand side after solving we got 15, in the right hand side after solving we got 9. So as our LHS and right hand side, that is RHS, are not equal, so we can say that this given statement is false and they are not equal. Okay, so in this way we will going to solve the expressions. Next one, the next exercise which I've taken is exercise from exercise 1C, that is page number 21, the question number 7. In this question we have to solve the given expression by using BODMAS rule. So here I have taken question number 7, number D. So this is a big expression which is provided over here. We have to solve it. So first we will write it down, the BODMAS, and first we will see the bracket. So we have curly bracket, square bracket, line bracket. So first we will solve this line bracket. So inside the line we have 6 plus 1. So first we will solve this 6 plus 1. So and 6 plus 1 is 7. In the next step we have written everything as it is, only this line bracket is being solved. Now next is you have to solve this small bracket. So inside the small bracket we have 9 into 7 and 13 into 3, and in the bracket we have this subtraction sign also. Now in the small bracket you have to follow the BODMAS rule. So in the BODMAS rule, after bracket we have division, multiplication, and then subtraction. So first we have to do the multiplication and then we have to do the subtraction. So we will multiply. So 9 into 7 is 63, 13 into 3 is 39. After that we will solve this small bracket. So 63 minus 39, we are getting 24. Okay, after this minus is already there, so this minus will go with the 24. Now we will solve this curly bracket. So in the curly bracket, first we are 3 integers are given, so first we will solve these 2 integers. So 3 minus 24 is minus 21, and then we will solve minus 8 minus 21, that is minus 29, and this 2 is outside, this minus is outside. Then we will solve this square bracket. In the square bracket we have 2, then this minus and minus of the 29 will become plus, so minus minus plus, so minus 17 plus 2 plus 29, and 29 plus 2 will give you 31, and then 31 minus 17 you will get 14 as the answer. So in this way we will going to solve by using a BODMAS rule. When it is a big expression, we have to be more careful. We have to go step by step. One expression at a time should be solved. Okay, not to be hurry. We should not go to the 2-3 expression at a time. Only one expression at a time. Then surely we will get the correct answer. Now we will see what is the home assignment. So for the home assignment, we have page number 17, exercise 1b, question number 4, all. Page number 21, exercise 1c, question number 5, and question number 7, all we have to do. So in the question number 5, it is this kind of table. Okay, this is the question number 5. You can see here question number 5. Complete the basic multiplication in the given table. So it is just a basic multiplication table which we have to solve over there. So how we are going to solve is, here it is written 1, here it is written 1. So 1 into 1, and then answer we have to write here. Like 30. How we got this 30? So 6 is here. We have to see vertically, we have to see horizontally, and then we have to multiply. So vertically it is 6, horizontally it is 5, so 6 into 5 is 30. Similarly here, for example, in negative sign, minus 20, so vertically minus 5, and horizontally it is 4, so minus 5 into 4 it is minus 20. So in this way, whichever block you are taking, suppose you are taking this block, so vertically you have to see it is minus 8, horizontally it is also 8, so 8 into minus 8, minus 64, and then you have to write here the answer. So in this way you have to solve this multiplication table.